start off, C2H6. So first thing we have is we know we have two carbons. So I have a carbon out here. Now what we know for these carbons is we look at the periodic table, we see carbon has a valence of 4. So each carbon wants to make 4 total bonds. And so I have 1, 2, 3, 4 for this one, 1, 2, 3, 4 for this one. I have 6 hydrogens. Each hydrogen has a valence of 1, so each one wants to make 1 bond. Let's just take a wild guess here. Let's say there's an H down here. 1, 2, 3, 4, 5, 6 like this. That uses up all my hydrogens. My hydrogens are happy. My carbons, though, are short. Each one needs 1 more bond. And well, there's a simple solution to this. Since they each need 1 more bond, let's just join them up. And so we'll join this bond up right here. And so now this would be a proper structural formula for C2H6 because each of the carbons has 4 bonds. And we have 2 carbons. Each of the hydrogen has 1 bond like they want, and there are 6 hydrogens. So this would be the structural formula for C2H6. Let's look at our next one, calcium hydroxide, CaOH2. And so for this one right here, let's start off by looking at the calcium here. Our calcium, if you look at the periodic table, it has a valence of +2, therefore it wants to make 2 bonds. So it makes 2 bonds off the calcium. Our next part here is OH2. We know the oxygen wants to make 2 bonds. It has a valence of -2. Hydrogen wants to make 1 bond. But this is a case where, remember we talked about polyatomic ions? This OH, since it's a polyatomic ion, means it travels together. That means we know that the O and the H are going to be connected. And so if I have an O over here, this oxygen wants to make 2 bonds, I know that it's going to have 1 hydrogen after it. And so I know for my other oxygen, when it comes off here, it's going to have its 1 hydrogen off of it because those OHs travel together. And so we got these 2 right here. But where will they connect? Each oxygen needs to make 1 connection to the rest of this whole thing. And, well, the calcium needs 2 connections. Each oxygen needs 1 connection. And so our most likely situation here is that these oxygens will connect to the calcium. And so we'll erase that guy for a second, and let's go ahead and put these in. And so that means we have an oxygen on this side, an oxygen on this side, and each oxygen, because it's hydroxide, is connected to 1 hydrogen. And I'll have to draw that guy down there. So if we look at this, let's make sure it works. We have 1 calcium, and each calcium should have 2 bonds, and this calcium does have 2 bonds. We have 2 oxygens. Each oxygen should have 2 bonds, and each oxygen does have 2 bonds. And we have 2 hydrogens, and each hydrogen has 1 bond like they like to be. And so these would be the ways, that's how you would draw out the structural formula of calcium hydroxide. Let's try one that's a little more complex as our last example here. C6H12O11, or sorry, C6H12O. So to get this guy to work, we know we have 6 carbons. And so let's try something out. Let's say we have 6 carbons here. So I have 1, 2, 3, 4, 5, 6. And let's just connect these guys up. We'll make a chain. Carbons like to form in chains. And so that usually gets you around. This is actually one of the reasons why these are called organic substances, because since they can form in chains, they can form basically as large of a molecule as they need to. And so they're used a lot in living things because of the fact that they like to form these long chains, because they can basically make just about whatever they want to, because these long carbon chains act as like scaffolding. And it's sort of like building something out of Lincoln logs or something like that. You can just sort of put them together in whatever structure you want to. And so we have each carbon wants 4 bonds. We have 12 hydrogens. So let's see where these 12 hydrogens could go. And so let's put these, we got 12 on here. So we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. We still have 2 more bonds left for the carbon, and we have an oxygen which needs 2 bonds. So what can we do to get that oxygen? It's 2 bonds. Well, remember we talked about double bonds before. The oxygen could take a double bond, and so to do that, let's go ahead and take a look at what we've got there. So let's look at put our carbon back here. If it's going to double bond, it could double bond out here to our last oxygen. And so let's take a look at what we've got. We have the first carbon right here has 2 bonds to the oxygen, 1 bond to a hydrogen, 1 bond to another carbon for 4. All the other carbons have 4 bonds. All the other hydrogens have 1 bond, so everyone's happy about their number of bonds. We have 6 carbons like we should. We have 12 hydrogens like we should. We have 1 oxygen. So this would be a possible structural formula of C6H12O. Now, let's try another one. C6H12O. Instead of putting the C's in a line, I am now going to do them a little differently. Bond, 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 bond. We have a circle. It's called cyclohexane. And so each C needs 4. So we've already got 2 because they all connect to the other 2 C's. So we add 2 more. So they'll get their total number of bonds up here. So now each C would have 4 bonds here. I have 12 hydrogens. So let's put these hydrogens in here. So I have a hydrogen. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. I could put a 12th on there, but I'm missing my oxygen. I need to put my oxygen somewhere. So let's attach the oxygen out to this carbon right here. Whoop. And if I do that, then I've got that oxygen needs 1 more bond, right? And so because the oxygen needs 1 more bond, where's it going to go to? Well, that 12th hydrogen here. So by the time I'm done here, I have 6 carbons, each one with 4 bonds. I have 12 hydrogens, each one with 1 bond. I have 1 oxygen, which has 2 bonds. These 2 structural formulas are both acceptable ways of writing out structural formulas for C6H12O. These are just different isomers of that of C6H12O. I would accept either one for your answer, and it turns out there are actually about there are probably a couple dozen different isomers of C6H12O, any one of which is correct. So if you wanted to do this, this is in either one of these I would accept. So this is basically how you write out a structural formula. And so that's all we have for this lesson right here.